So the Digital Technologies unit that has been developed takes a focus on the idea of outer space, hence the SpaceX title. So the idea is that the students have been hired by NASA to program a robot to either communicate with another life form or to travel to a planet and explore it. So all the activities and tasks that the students will undertake will relate back to that focus. So whether it's when we're looking at the different data transition methods, we're looking at whether it's sending data through via satellites, using the space station, all those kinds of things. And when we're looking at binary, it's a binary message that's been sent from the aliens from outer space to help the students connect it and relate it back to some sort of real life scenario. So with the program, every worksheet, link, everything like that has been hyperlinked in there for you. If there's any issues with that, please contact us. But definitely all of the worksheets and all of that I mentioned are in the student workbook. The student workbook has different activities that you can leave if you're away or whatever else, but they also build on and continue with that theme of the SpaceX. So all the different tasks in there will, if they're an informal task, they'll have the outcome that it's mapped to, as well as a marking criteria that you can then use as part of your reporting if required. All of the formal tasks of the folio are also embedded within the student workbook, but if you choose to, you can also, they're separated in a different document there for you to make it easier. I do encourage all schools to have a look at the different resources developed and change them to suit their need. Depending on what programming language or what robot you're using, you may need to manipulate some of those. Our school will be using MBOTs, and so behind that we have definitely taken a focus in that when developing up these resources. But please have a look, feel free to change the scenario or anything like that as required. So the assessment task that's been developed is a bit open-ended, just to encourage schools to create their own scenario based on the resources that they have. The main part of the assessment task takes the focus of the design process and works the students through that with using all the different content and stuff that's already in the unit. There is nothing that's really been thrown out in there just because or for sake. It's all based on the different outcomes that have been listed there for the particular unit. So the students will, for example, be looking at the different requirements and constraints of the design scenario that is produced by the school, looking at the different hardware that will be used to teleconference with NASA and seeing what they would need and all that pertaining to purchase it. Then they'll be able to look at the different hardware within the robot themselves that they'll be using and the best way to use the sensors, the actuators and stuff like that. Then they'll make a design criteria that they will use then to assess later on. In this process, we've taken a bit of a focus on the idea of ongoing evaluation, and you'll notice that throughout the booklet at the end of each section of the design process, the students are then encouraged to go back and evaluate what they've done or get peer feedback. And that brings me to the next part where they make a logo and a storyboard that their peers will then help them evaluate that, and then they'll make a better version essentially. With the logo, they'll be developing that using binary to see that the way that pictures are represented using binary and how computers do that. Students will then go on to make their particular program and testing with their robots and making sure that you also carry in that general purpose language like discussed previously. That will all then be presented on a website. We'll get our kids to also annotate their code just so that we can see how well they understand and how fluent they are in the different languages that we're using. In the testing and evaluating, the students will go through that process of debugging their codes, and in keeping their diary log, they will then also be looking at the different ways that they will be able to fix and manipulate problems, which also brings them back to that positive mindset in being able to say, yes, I have all these challenges, all these things different work, but I learnt from them, which ended up giving me a better project in the end. All of that is encompassed in the criteria that is provided. Please have a look at that, see if it serves your purpose, if you need to manipulate or change things, please do that to make it better for the kids and more relatable to what the resources you have. In regards to managing the project in the classroom, it's up to you how you do that and how your school does that. A couple of options that you have is that you could have the students make their own models that the robot interacts with using its sensors. You can bring in other different technologies then, so some textiles or some timber, depending on the restrictions you set with that. Another option is that you can develop a map for the whole class or grade that the students interact with. We've done that, so you can see like we've developed a model where the students have to use their line follower sensor and their LED lights to be able to turn them on in tunnels, and their light sensor. Then they're using the ultrasonic to sense distance, and in this particular scenario they're saving Mickey Mouse from a chemical spill. So in that, it's up to you on how difficult you make that and how much they have to interact with their robot, or whether the robot has to be totally autonomous and have no touching and only carry out a particular task. That's totally up to you.